It's really good to have you guys here. And maybe we can start from a few sentences to introduce yourself and the projects you're working on, starting from Ben.
Yep, I'm Ben. I'm a contributor at the Uniswap Foundation working on the V4 hooks ecosystem and go to market. Spending a lot of time with our developer community, the emerging hook developer ecosystem, as well as supporting that developer ecosystem with our grants program, the first of which are underway, and the next round of which will likely be announced sometime in January. So excited to be here and chat about hooks, co-processors, and how they work together with two of the most exciting teams in the space. So thanks again for having me and for inviting me to speak here and discuss this with you.
Thank you, Ben. And Xavier.
Hi, so this is Xavier from PADO Labs. PADO is a decentralized attestation protocol with a vision to bring in all internet data into smart contracts. And I'm the DevRel and also a researcher in this team. So I'm very honored to join today's space as a speaker for PADO Labs. And also we built a prototype on Uniswap v4 recently by creating a couple of specific hooks. So that's why we joined this talk. And in general, we made a compliant pool where all the validated people can do the operations like swapping and adding liquidity. So we think this will be very useful for some domain-specific use cases. Yeah, thanks for that.
I think your connection is not quite stable, Xavier. But anyways, let's carry on. Wanli.
Hi guys, it's Wang from Brevis. So Brevis is a smart ZK coprocessor that empowers smart contracts to read the full historical on-chain data, and at the same time we can run customizable computations in a completely trust-free way. We're very excited about the opportunity to support both Uniswap v4 hooks as well as PADO for features driven by on-chain data. And really nice to be here in this tour space. Thank you guys for inviting me here.
Hey, thank you guys. And can you introduce a little bit more like on what is the hooks and what are PADO and Brevis building for hooks and what is a coprocessor? And maybe starting from Ben, can you introduce a little bit about hooks on Uniswap?
Yeah, definitely. So Uniswap v4 is going to be the latest iteration of the Uniswap protocol. Among a few other big changes, the most notable is, of course, the addition of what we're calling hooks. Hooks are callbacks that developers have access to within the lifecycle of a pool, whether that's before or after the initialization, before or after modifying a position, before and after swapping, and before and after a function called donate, which is we see being used for liquidity mining. We've seen 100+ hooks created so far by the community. You can check out uniswaphooks.com for our community registry of proof of concept hooks and check them out on GitHub, look at all the different hackathons and independently created hooks that we're seeing. We think that V4 and hooks turn Uniswap into the ultimate DEX platform and essentially a universal pool settlement layer for the EVM. The expressivity that hooks allow have already exploded the sort of DEX design space while piggybacking off of a singleton design where all pools live within the same smart contract, benefiting from more efficient multi-hop routing within the protocol. So we're seeing a number of exciting use cases across the spectrum for both LPs and swappers from the developer community, from lever mitigation or redistribution mechanisms like the one being worked on. I see we have someone from Arrakis here. Arrakis is working on something really cool on this front. So is Sorella Labs with their Angstrom protocol to help LPs better manage and become more profitable in an active liquidity world. We're seeing what I'm calling hybrid DEXs. So DEXs who have implemented themselves instead of a completely end-to-end smart contract as a set of hooks with potentially their own interface, as well as the ability to get the sort of hybrid routing flow from not just their interface, but the rest of any V4 pools, anyone routing to V4 pools deployed on the chain that they're on. So we're seeing Bunny from Timeless Finance as an example of that. what I would call this hybrid DEX, a very exciting set of use cases. We're even seeing lending protocols utilizing the singleton colocation model, if you will, for trustless liquidations and more efficient liquidations, like what has been proposed by the Solvent network, solvent.network. From across the spectrum, we are really seeing a ton of different innovations on hooks. And I would say the way that I think about coprocessors and where hooks and coprocessors and why several months ago I picked up on this article that's pinned at the top here from 7X Ventures, which I think really nailed it and set a lot of my thinking in motion around this. And I'm sure a lot of everybody else here has taken a look at it as well. And basically, we have all this functionality, this expressivity, this ability to add custom order types, to add dynamic fees of different kinds, to add also potentially even having your liquidity when it's out of range deployed into a lending protocol or an ERC 4626 vault, etc. The sky is the limit from a functionality perspective. However, of course, we're still computationally and gas constrained on a general purpose network like Ethereum or even on layer 2 networks where deployed. So this question of how do we scale hooks and how do we fully explore the hooks design space and get the most out of that has led me at least naturally to this coprocessor concept, both for on-chain data like what Brevis is providing, or off-chain data like an off-chain data coprocessor, an off ZK Oracle like what PADO Labs is providing. We actually are also seeing some other categories of coprocessors emerging as well. But I think the big picture on coprocessors and hooks is hooks open up this infinite design space, but we are still constrained in terms of computation. We are still constrained in terms of what kinds of calculations we can do on the data to unlock this functionality. And potentially with these coprocessor designs, these hooks can scale almost infinitely, at least in terms of what we need them to do, without, let's say, a purpose-built network just for, it can be essentially scaling outwards from the application, which is a perfect fit for something as expressive as hooks. So I'm very excited about what's possible, and these two projects working on pushing forward examples of things like prove your Binance largest trade off-chain as a part of the logic to let you either swap or LP in a pool, as well as prove your largest trade on-chain. And the combination and composability of those different types of proofs within a hook, I think, unlock extremely powerful design patterns that we're only at the beginning of scratching the surface for. So yeah, that's kind of how I see V4 and coprocessors fitting in. And
this space was downloaded via spacesdown.com. Visit to download your spaces today.
I'd love to kind of hear more from the folks at Brevis and PADO about kind of the POC that they've been working on, some of their thoughts on the space, and we can discuss from there.
Yeah, that's a very comprehensive introduction of hooks of Uniswap. And been talking about the co-processors and the ZKR codes you mentioned. So what about next? We're diving into the introduction of each project from PADO and from Brevis to introduce a little bit what are exact the use cases separately are and what kind of potential of combined use cases for PADO and Brevis. So maybe we can start from Xavier. Can you talk more about the hooks, like building on hooks on Uniswap?
Okay, yeah, sure. So I think Ben already introduced very clear concepts and the use cases of Uniswap's hooks. So in my understanding, so PADO are always looking the opportunity to combine the internet data with on-chain scenarios. And when we meet the release of the Uniswap V4 hooks, we think this could be the most important feature we ever met. So basically, people can build, let's say, customized and a very flexible code which can inject into their pool process. And as Ben said, the on-chain operations are very expensive. So that's why we need some co-processors to handle it with. So The demo we built is about we can create a compliant pool for people to join in. So basically, this will be very useful for some specific domain like compliant finance. Just imagine if the people only with validated off-chain status can be passed into the swapping or liquidity operations. So in that case, we can build some we can simulate some financial applications just like the traditional finance do. So PADO is a typical coprocessor, but it has some differences with some other ZK processors or coprocessor projects. So basically, we are focusing on the off-chain data, which means we can bring in people's off-chain data into the smart contracts, and we can create arbitrary computation on this data. So some use cases like we can build either with hooks or without hooks, but just like some quick examples, like we can create some very specific DeFi, say DeFi pool or DeFi, let's say lending stories. So people can prove their off-chain assets data. And for example, if I can prove I already have some money in Binance, and I can post this proof to the blockchain, to a smart contract, and the dApps there can verify that proof, and then it can return me some rewards or some incentives for that. So this is a very general workflow for users to operate, but it can bring in very different use cases for that. So we think DeFi will be a very big portfolio for PADO to create different kind of use cases on that, and also we can expect more use cases rather than DeFi, but with other domains as well. So yeah, I think this is my understanding for the problem.
Thank you, Xavier. So let's carry on to Wan Li. Can you introduce more about the co-processor Brevis working on Uniswap before?
Definitely, thank you. Yeah, so I think Ben as well as Xavier have already introduced a lot about the co-processing space, and there are definitely different types of co-processors focusing on different verticals. And for Brevis, our key focus right now is data access and computation on the full historical on-chain data, like Ben just mentioned. And we're specifically focused on Ethereum for now, but we have the plan to expand to other blockchains like BNB and Polygon. They're within our timeline. And several key features that we are offering are firstly omni-chain support, meaning you can compute on Ethereum's data and push that to a BNB chain contract. And this definitely allows for opportunities like ZK bridges or multi-chain native dApps. And secondly, we also offer on-chain data readability and computation. And because of that, it can empower data-intensive features based on users' on-chain transaction history, for example, and in the verticals of like gamified projects, they can segment users based on their interactions within a game and build distinct user journeys accordingly. And in the case of Uniswap v4 or any other DeFi protocols, you can feel free to check out our Uniswap v4 demo hook, and which shows a way for a hook contract to basically allow discount fees based on a trader's task trading volume. So if you trade more, you definitely gain better benefits from the pool. So these are examples of what Brevis can enable for decentralized applications. And we think like focused on-chain data is our basically unique focus right now compared to other co-processors. Thank you.
Cool. So can Wan Li, maybe can you explain a little bit on what is the joint, the combined use case from PADO and Brevis can potentially bring to Uniswap?
Yeah, definitely. So for the demo hook we have built right now, we are only allowing a hook contract to read into the data on chain. So basically, they can tell if a user has completed a certain amount of transactions in the past, or if a user has been using Uniswap v3 for a certain period of time, and that is like purely based on a user's on-chain data. But with PADO, we can combine these different facets of a user's identity and allow Uniswap V4 hooks to see if a user is qualified for certain pools or certain features within the pool. And that definitely brings more possibilities for user segmentation and trying to cater to different user segments with unique features to allow more customized user experiences.
That's great. That's great. So talking about the combined use case. So Ben, how you say the difference between because there are so many different kinds of coprocessors. So what is the difference between them? Like what in terms of the design for the hooks?
Yeah, so I think it's still very obviously early in terms of this design pattern, and where we decide to put things, I think is still kind of up for discussion. But I think broadly, one sort of meta category that we're seeing is, obviously access control, but smart access control. So access control either to the pool or in order to swap, or both. And kind of the sort of very, I guess, obvious version of that is some version of KYC or permission pools for institutions, or potentially kind of like a ZK KYC using something like PADO for kind of retail. But in the mechanism design space that Hooks opens up, there are other things than just simple access control for its own sake, that knowing something about your user and something about their, let's say, their past is useful for. So in the case of the demo that you guys have put together around showing the proof of, let's say, both a Binance trade in the past on Web 2 and a Uniswap trade in the past on Web 3, to establish some kind of VIP trader program or access to the pool based on your history, that could create an interesting game theory in terms of what kinds of market participants are able to join, and therefore what kinds of liquidity can be recruited to serve that use case. And if you take it a bit further, we are seeing sort of this dynamic fees design space being explored, both with and without coprocessors. This is the idea of charging different fees based on who the participants are, and potentially the holy grail of this being discriminating between, let's say, toxic and non-toxic order flow, or between a retail swapper or a power user swapper versus kind of an arbitrage bot. And dynamic fees are potentially very computationally intensive. And so some of the algorithms, some of them are very simple, but some of them are quite complicated. And in order to actually scale that and get that to work, it may be the case that those algorithms need to be implemented in something like a coprocessor logic. So that's sort of the beginning space that I'm starting to see emerge. It's around access control for kind of the off-chain component, and bringing your Web 2 data history and maybe trading history or financial history or credit history or something else to the mix. Proving something about your on-chain history and what that says about you, and potentially giving you access to a trading discount or something to that effect by verifying that you're at least a dolphin or a whale, or something to that effect, or that you're not, in the case of dynamic fees, demonstrating that your transaction is not an ARB transaction, or something to that effect. So that's the initial area. I think there are more speculative and futuristic concepts to be unpacked here, with not just scaling the data access side, but actually computation and execution itself. And so there's some interesting designs which almost use the coprocessor as like a sideways roll-up to essentially give you, I don't want to say unlimited gas, but sort of a development experience where you're very unconstrained as a developer building something like a V4 hook. And as we've discussed earlier, that expressivity and the network effects through routing through the singleton are a pretty powerful combination. And so if we can get basically hooks to be as unbounded in what they're potentially able to do as possible, we think that the entire sort of liquidity design space can be explored on V4 efficiently, potentially even on layer 1, not just layer 2, which is pretty interesting. I don't know if anybody else has thoughts, but that's kind of what's on my mind about it.
Yeah, I guess you talk about the discounted trade based on the coprocessors. So what about talking more about like examples that use both Brevis and PADO coprocessors to trade on on both CEX and DEX history. And Xavier and Wanli can talk about how PADO and Brevis different from the traditional oracles in terms of the off-chain data and on-chain data.
Yeah, so I mean, from my perspective, I think like a very simple one would be to demonstrate that you are able to trade in some size, both on and off chain. Obviously, the proof of reserves problem has not fully been solved through things like ZK proofs. There is still the question of kind of you couldn't necessarily prove solvency based on, let's say, your Binance balance or your largest Binance trade, nor could you do the same by sort of proving on chain how big your balance in a particular wallet is, etc. But the heuristics may be useful here. If you've ever been able to trade in the past, made a trade $100,000 off chain, or you'd made a trade $100,000 on chain, that may be enough to put you into a different fee tier. And exactly what the mechanism design is to incentivize may differ. You may have a pool that tries to encourage whales to be swappers and retail to be the LPs, or the reverse. So I think it very much depends on kind of like where the liquidity market fit that the hook developer is trying to accomplish ends up being. But I think that essentially some kind of big enough proof of something that you've done in the past is kind of a starting point for more advanced and more kind of granular, let's say, logic, segmentation logic, pricing logic, etc. Would love you guys to go into a bit more detail, maybe on what that looks like from a perspective of Brevis and PADO together.
From PADO Labs. So the use cases which Ben already talked about is maybe like we can using the people's trading data from either off-chain and on-chain. And from my understanding, also there will be more possibilities. Like you can bring your off-chain identity, and maybe you can link this identity with your some of your on-chain behavior data to feed it into the pool. So maybe we can create some kind of reputation system with the pool, and this reputation system will consist of either your off-chain identity, which will be some kind of long-term data like your gender, your age. But this data will be protected for the privacy, definitely, and also will be combined with your on-chain transactions or some other on-chain behavior data. So, and considering the problem of the PADO's differences from the traditional Oracle for off-chain data, so Oracle protocols like Chainlink, like PICE, maybe they are more all type of public oracles, and they can help us with feeding the public off-chain data into the blockchain. And maybe the most frequently used data could be the finance data, like the price, like the exchange rate. So we can use that for creating some protocols like stable coins, like on-chain lending protocols. Maybe we can use aggregated data to do the clearing. So in general, PADO is a type of private oracle. But it's more than that. So one hypothesis is that we think people's off-chain data will be very useful, will be a big impact on Web3 DApp, especially on the data-driven DApps. So unfortunately, the power of the private data has already been proven in the traditional internet economy. And the private data, and an interesting thing is we can create a type of decentralized recommendation system for the users. So just considering people can fetch their web data from the off-chain data sources and can manage this data locally. And if they want, they can contribute their own data to some type of, let's say, zero-knowledge machine learning system. And the ZKML will doing some model training, and they will derive a specific model for some DApps. So this kind of, let's say, the data infra will be maybe a good choice for some protocols like on-chain advertisements, maybe some retailers like cold wallet sellers and some other DApps. So some other applications of using private off-chain data, maybe for example the decentralized identity system. So you can really process your credentials from your web data, and we think this will be a much lightweight but still very reliable way to create this kind of the decentralized identity system. Comparing some existing system, maybe they are relying on some heavy identity issuer. So yeah, I think this is a crucial differences between the PADO and the other Oracle protocols. Thanks for that.
So what about Wenli? Can you explain a little bit about how Brevis is different from the traditional oracles for on-chain data?
Yeah, definitely. So basically, I would say we are not exactly positioning Brevis as an oracle because oracles usually are tapping into like reading the data, whether it's off-chain data or on-chain data. But like Brevis is more focused on data-rich computation. So the computation efficiency is one major focus of our dev experience, basically. So I think the customizable computation capability that Brevis offers definitely isn't one way to distinguish Brevis from the rest of other types of coprocessors. Another is our data focus. So compared to PADO, which is more focused on maybe real world asset data, we're more focused on chain data for states, transactions, and many others. And how Brevis works is it offloads data computation tasks from on-chain from the hands of smart contracts. And Brevis will basically handle the computation for on-chain data, and then it will push a simple result as well as a ZKP back to on-chain to the smart contract for direct verification and use. So this entire flow might be a lot different from traditional oracles. And another way of thinking, basically, what's the major difference between the current ZK coprocessors compared to traditional oracles is how trustless we are. Basically, traditional oracles usually would rely on a set of validators, making them like tending to be centralized compared to the trust assumptions of L1. And an oracle is able to accurately whether a piece of information back chain is correct or not is dependent on the trustworthiness of their validators. But ZK coprocessors, since we are utilizing zero knowledge cryptographic algorithms to achieve trust minimization, the entire process would not introduce any new trust assumptions. So we're purely based on the original trust assumption of the L1. These are basically what separates Brevis from traditional oracles, I would say. We're more focused on computation. We are trustless. We also allow for customizable computation. Developers can easily use our SDK to basically tap into the various data-rich computation opportunities without caring about how to write a circuit.
Yeah, and this reminds me of something. I want to point something out as well, which is interesting to contemplate relative to V4. So the V4 removes the TWAP oracle as an enshrined piece of functionality. And in speaking with the Uniswap Labs team, the most likely default hooks or pools that they will launch with V4 from their front end to start will be sort of vanilla V4 pools with no hooks, so just concentrated liquidity, so that the gas tax, I think there's some crazy number of how much we've all paid in gas for the TWAP Oracle, as useful as that has been in DeFi as a sort of price feed and a source of data, that has been removed from the protocol as like an enshrined piece of functionality. So there's both the concept of, let's say, the oracle that the V4 pool or a Uniswap pool in general produces by its sort of trading function as acting as itself the price feed, which is an interesting principle of AMMs It's why, for example, we're seeing lending protocols experimenting with the idea of a Oracle-less liquidation hook that uses the actual pool to determine the liquidation price. There's also obviously the concept of, so that's the concept of what kind of oracles do the sort of pools produce, let's say. And that can be customized in hooks. You can create custom oracles. People have experimented with a geomean oracle instead of a arithmetic mean oracle, truncated oracle. Sorry, there's a thunderstorm in the background here. And embedding those functionalities into the hook pools. And that might be for a token project who needs a particular type of oracle on their token. And so their pool is producing this type of custom oracle. The other way to look at it is, and that type of oracle, the one that's produced by the pool, can also be implemented, is my understanding, rather as a lookup with something like a coprocessor like Brevis, an on-chain data coprocessor. So there's an interesting question of sort of, in the future, do you need the hook to create the oracle or enforce the oracle logic itself, or does the coprocessor's ability to look back trustlessly on the chain's history give you the functionality? There's a reason folks are also calling them kind of like these ZK oracles or these like super oracles for that reason. The other sort of type of oracle in relationship to the pool is like the oracles that the pools consume. And the very simple version of this would be setting up a V4 pool which just asks for the Binance price via Chainlink Oracle or something like that. And so I think there's a very interesting set of questions that span both what are the oracles that should be implemented as V4 pools or inside of V4 pools? What are the types of oracles that are replaced by coprocessors in general? And then what kinds of oracles do V4 pools want to consume in order to, let's say, synchronize prices better on and off chain or whatever the use case ends up being? So I just wanted to point that out because it's a pretty interesting, there's a lot to do there in between the different versions of the Oracle question, and it's very intimately tied up with the coprocessor one.
That sounds really interesting and kind of making the whole community really vibrant using V4 hooks, other than just talking about technology. Also, kind of bring up the idea we have for like how to build a really vibrant, enthusiastic, and active developer community. I think that's also why we're so excited about V4 hooks, and it's really great, and it provides a good opportunities for co-processors, for PADO, for Brevis to play the role inside, and the collaboration between on-chain and off-chain really make applications more diverse and colorful in the future, and that's really good. And thanks so much for coming to the space, Xavier, Wanli, and Ben. And that's pretty insightful for today's session, and bring me at least a lot of insights and thoughts about Uniswap V4, about PADO and Brevis. And thank you for your time.
Thank you so much.
Thank
Thanks,
you.
everyone. Excited to see what you build.
Yeah, so that's the end of our session. Bye.